Welcome to the Geometry Nodes tutorial. This tutorial is part of a full course where we will make a floor generator. We will create several most common floor patterns with geometry nodes, then we'll combine them together to get the generator with which we can easily switch and set up the pattern we need. We will learn how to set up geometry nodes that adapt to the mesh so that it will be generated only on the selected area. Also, we'll create an adaptive shader that allows us to make a unique pattern for each board using one texture only. Check the playlist for all chapters. And if you are ready, hit subscribe button and let's begin. In this part we'll set up a classic pattern with a half offset using geometry nodes. Let's start from the quick overview of our node tree. We begin with grid as base mesh. Then we use separate geometry node. We use it to separate every second line of a grid. Then we use set position node to offset one of the parts of our geometry. Join both parts of the geometry together with join geometry node. After that we use split edges node to make each floorboard separated from the rest. And then we add a thickness to our floor with extrude mesh node. These are the main points of the logic. Let's look at the steps in more detail. Let's look at the settings of our grid setup. Hold Ctrl-Shift and then click on the node to connect fewer node. We'll start with setting up a single board. This is the x-axis size parameter. To get the size of the whole grid, we have to multiply the size of one part by their quantity. So I use size x value and multiply it with math node by quantity. Also need to connect quantity value to vertices of grid node to get grid subdivision instead of a one single piece. If we connect quantity to vertices directly, it will not work correctly. As we can see, I've set quantity value to 5, but got only 4 pieces. This is because the node requests the number of vertices, not segments, and 4 pieces have 5 vertices. So we need to add 1 with math node to make quantity parameter work properly. Use same settings for the y-axis direction. I'll return the parameters to make it more clear visually. The next step is separate geometry node. Set domain to faces. And for selection socket we will use the selection based on face index. We select every second line using floored modulo operation. It's a math node set to floored modulo operation. Just connect the nodes as shown on the screen. Quantity y parameter is the parameter that we used for the setup of grid. I just duplicate them so as not to make the wire too complicated. Now, if you connect nodes in the right way, separate geometry node will give us each second line of our floor. Add join geometry node and connect both parts of geometry. And for one of the parts of geometry, add set position node. We will make an offset along the y-axis. If we connect size y directly, we get an offset over the entire length of the board. But we only need half the length. Add math node and multiply size y value by 0.5. Now we have a classic parquet pattern with a half offset. To make more patterns, we may add an offset control. Add mix node in float mode. Set position A and B. Now you can control the transition between positions A and B using factor. Add split edges node. We need to make each face a unique mesh island. Without split edges node, one line is one mesh island even if this line is subdivided. Enabling split edges separates the faces from each other. It It gives us seam detailing and will be useful for the shader setup. And the last node, extrude mesh node, to add a thickness to our floor. Add bevel modifier after our geometry node tree to make bevel and get a nice details. So that's all for this part, and see you in the next ones. Jump into the next part to learn how to make the floor shader that will have a unique pattern for each board, and troubleshoot the most common issues